or some different file, right? Now we are trying to creating one directory called readmi, right? Readme. Okay. So now readme is a one directory. How to know the properties of readme? Uh, so we doesn't have any ACLs for readme, right guys? We'll have only dot. Dot means no ACLs. So get FACL readme. See guys here, we doesn't have any special ACL permissions. So default ACL permissions will have. Now what we have the permission for Oppo, the same permission we need to apply for Redmi. How you're going to apply? You need to assign manually, right? If you try to assigning manually, so how much time it will take? It will take long time, right? Yes, no. Instead of assigning manually, we are trying to copying the ACL permission from Oppo to Redmi. I hope you got it, guys. We are not copying the data. We are copying permissions, ACL permissions from Oppo to Redmi, right? So now let's see, guys, here. Get FACL, how we need to copy. Get FACL command, what it will do? It will list out the ACLs, right? Get FACL source file name, Oppo. Oppo is a source, that's it, no? What we have the permission for Oppo, same ACL permissions we need to provide for Redmi. Pipe. Okay. Then get FACL. Sorry, set FACL, not get FACL. Okay. Set FACL. Get FACL Oppo. Set FACL hyphen set hyphen file is equal to colon space Redmi. Right, guys. So this is an option. Okay, from here to here. Guys, here you need to provide one space. It's mandatory. Without providing the space, you are unable to execute the command, right? So here you need to provide the space. Okay. So this output, what we are getting the output for Oppo, the output we are trying to assigning for Redmi using set FACL set hyphen file option. Most of the people they doesn't know this. Clear? Hyphen set hyphen set hyphen file is equal to hyphen. This is an option we are going to use. We are going to get the Oppo ACL permission and we are assigning for Redmi. Got it? Hit enter. Check the list. See, before we doesn't have ACLs. Now we got a ACLs. We didn't assign any ACLs manually here. Get FACL Redmi. See here. Got it, guys? Redmi also having the same Oppo ACLs permission. How will have the Oppo ACLs permission? Like the same way Redmi also will have. I hope you got it, guys. Clear? So like this, you can copy the ACL from one file to another file, one directory to another directory using this command. Okay, using this command, right? We know how to assign the ACLs, how to copy the ACLs and everything, how to assign the default ACLs, everything we know, how to modify the mask, everything, right? Now, how to remove the ACLs? Without knowing this, how you're going to become as an administrator? We should know how to remove the ACLs, right? So how we need to remove the ACLs? Set FACL hyphen X is option for removing the ACLs. Set FACL space hyphen X is an option for removing the ACLs, right? To whom we need to remove? We are trying to removing for Raju. Okay. So we are trying to removing for user Raju from Oppo. We are removing the ACL permission for user Raju from Oppo directory. Okay. Get FACL Oppo. See guys, Raju now he doesn't have the access to create the files and directories inside the Oppo. Set FACL -x, then we are trying to remove the ACL for NIT group members. Right. Get FACL Oppo. See guys here. So we remove ACL permissions from Oppo. I hope you got it, guys. Clear. NIT group members also, they are unable to create the files and directories inside the Oppo now. Now we need to remove everything at a time. It may be user permissions, it may be group permissions, it may be default permission, whatever it may be. We need to remove everything at a time. Set FACL -b is an option, then Oppo is a directory name. That's it. B means we are trying to removing everything from Oppo directory. Get FACL Oppo. See guys, we doesn't have any ACL permission for Oppo directory now. By default permission we got. So if you want, you can check. So instead of plus, we got a dot again. So now we doesn't have any ACLs. So this is all about ACLs, guys. Okay, clear? If you having any doubts, any questions in ACLs, please. Yes, guys, online. If you having any doubts, any questions in ACLs, please. Now we are going to start 4:35 only. Now we'll start new chapter, how to manage the operating system process. -b means removing everything. Right? -b means removing everything. Right? Got it, guys? If you having any doubts, any questions in ACLs, please. What? Okay, man. Okay. I hope you doesn't have any questions, any doubts, right? Then we'll start next chapter. Okay, 11th chapter. So please focus on it. Really, it's a very, very important chapter, right? So how to monitor and manage the managing the operating system process is a chapter name. Process management also you can say. Operating system process management also you can say. Right, guys? First of all, my question is, what is process? What is process? What is process? So what is process, guys? Steps to do any operation. set of instructions. What is process? A running instance of a launched executable program that is called process. If I'm trying to teaching definition wise, like this will have. Okay. So what is process? A process is a running instance of a launched executable program. ఏమైనా అర్థమైందా? ఒక్క ముక్క అర్థం కాదని నాకు తెలుసు. ஒண்ணுமே புரியல எனக்கு தெரியும். ஒண்ணுமே புரியல. மஞ்சிதா கொஞ்சம் கொஞ்சம் புரியுதா? என்ன புரியுது? ஒண்ணுமே புரியாது எனக்கு தெரியும். தெலுங்கு புரியாது, உனக்கு தமிழ் தெரியும்ல? அப்போ தமிழ்ல பேசிட்டு இருக்காங்க. நான் இப்போ தமிழ்ல தான் பேசிட்டு இருக்காங்க. புரியலையா? Yes guys, what is process? And running instance of a launched executable program. What is the meaning of running instance of a launched executable program? Simple guys. We are trying to executing one command into our operating system, into our mission. That is called process. That is what I said in definition wise. So let's see here. So let's see here. अभी तक इमरान सर तेलुगु में बात कर रहा है बोल के कंप्लेंट, अभी तमिल में भी बात कर रहे हैं बोल के कंप्लेंट आ जाएगा. राइट. Let's see guys, this is bit important session. Please try to focus on it. So what is this? A process is a running instance of a launched executable program. A process is a running instance of. Running instance means running computer. Instance means computer only, right? Yes, no. Mission. Running instance of a launched executable program. We are trying to executing command that is called process into our operating system, into our mission. I hope you got it now, definition. So clear? So if you try to executing any program into our mission, that is called process, man. Simple. A process is a running instance of a launched executable program. So that is called process. For example, ls-l, if you're executing, that is one process. Cat command you're executing, that is one process. mkdir command you're executing, that is one process. You're trying to creating user, that is one process. We are providing the input to the system. It will take the input through input devices. It will process. Finally, it will give the output to us. That's it. Like sugarcane mission. We are going to put the sugarcane into the sugarcane mission, and then we are going to get the final output called juice. Like the same way, right? We are providing input. That is called process. It will take the input through input devices. The processor, it is going to perform the process, and then finally it will give the output for us. Right? Process consist. Okay. If you go to one process, if you're executing one command, that process consists what kind of property the process it having. So an address space of allocated memory. Always it is going to consume the memory. Right? It will an address space of allocated memory, unallocated memory. Okay. Security properties including ownership and credentials and privileges. Okay. Clear guys? Security properties, including ownership, credentials, and privileges. Security, properties, including ownership. Who's the owner? Who's executed that particular process? Maybe student user, maybe root user, maybe U1 user, maybe Raju, maybe Rani, whatever it may be. So that particular process ownership, right? So ownership, credentials, and privileges. So I hope you got it. It will consist one or more execution threads of the program code. It may be one or more threads will have into our process program code, right? And process status. As an administrator, we need to focus on process status, right? Then only we can able to identify the process. Then only we can able to manage the process. The process, it is in which status it having, we need to identify as an administrator. I'll tell you with the help of one diagram, don't worry. Easily we can able to identify the process status. Most of the people, they have some confusion there. Here we are going to discuss very clearly, don't worry, how we need to identify the process status. Clear, guys? Process consists those four things: an address space of allocated memory and security properties, including ownership, credentials, and privileges, one or more execution threads of the program code, process status. So clear? First of all, who's going to generate the process? An existing parent process, guys. We have parent process and child process. Two types of process will have. Those all the process says it will be available into one session. Simple, guys. Assume this classroom is one session. We are taking Linux sessions, right? In this classroom, this is one session, right? In our classroom, right? I'm a parent process. Faculty is a parent process. Next, child process, students. I hope you got it, guys. Clear? Faculty is a parent and childs are students. Like the same way here also, right? An existing parent process duplicates its own address space. The duplicate method, that is called fork. Right, guys? Fork to create a new child process structure. Okay. So simple, guys. Who is going to create the new child process structure? Parent process. I hope you got it. So I'm a Linux trainer. I'm trying to teaching Linux. You're going to become experts in Linux. Really, guys? Huh? So let's see here, like the same way. An existing parent process duplicates its own address space, that is called fork. The method that is called fork to create the new child process structure. Every new process is assigned a unique process ID that is called PID. Each and every students in Naresh IT, they having the one unique ID card. With the help of that unique ID card, management, they are going to identify the Naresh IT students. Like the same way. In our operating system, how many processes if you're executing, how you're going to identify those processes in a sense? With the help of one unique process ID, PID, process ID, for tracking and security. That's it now. How the management, they're going to track you? With the help of ID card, right? Yes, no. Really, he belongs to Imran sir class or not, how he's going to track? With the help of your ID card, right? Yes, no. Like the same way here. Total operating system is Naresh IT. Assume this. Okay. In our operating system, we'll have many processes. It's running into the background. Those all Naresh IT students. I hope you got it. How they are going to identify? with the help of process ID. Clear? Good. So the PID and PPID. PPID means parent process ID. And you are also having the ID card, and we people's also having the ID card. At present, we doesn't have. Okay. So usually management also having ID card, right? So we'll have few administrator, they are wearing ID card. So how they are going to identify? We have more than 80 people that are working as a non-IT staff into Naresh IT. Then how they are going to identify them? With the help of admin's ID card, parent process ID. So I hope you're clear, right? So now for 4 to 5 classes, one admin. Okay. For 200 peoples, one admin. For 200 students, one admin. Like this. One parent ID. So, and see guys here, the PID and PPID are elements of the new process environment, right? Any process may create a child process. All the processes are descendants of first system process, that is called system D on RHEL 7 and 8 and 9. From 7.0 onwards, they introduced to us first process ID in our operating system, that is called system D. Under system D, will have remaining process. System D is a remaining processor, descendants of system D. Descendants means वारिस, like वारिस ही है ना, क्या बोलते हैं వారసులు అంటారు చూడండి తెలుగులో. సో హిందీ में वारिस बोलते हैं ना. You are all my, I hope you got it now, right? So yes, no, like the same way. System D is a parent process ID. So inside the under parent process ID, we'll have all the remaining child process. All the processes are descendants of system D. I hope you got it. System D means demons. Demons, right? What is demons? The process, it's running and waiting into the background. If it is try to performing the various tasks, that is called daemon. One process will have, it's running into the background or it's waiting into the background. It's providing some services to us, clients. That is called daemons. Okay. For example, HTTPD, VSFTPD protocols, services, HTTPD protocol, VSFTPD protocol, right? SSHD protocol, those all demons. Demon means devil. It will work 24/7. The demons, it will start along with the boot time, right guys? Demons, it will start along with the boot time until you shut down the machine, or otherwise until you need to stop the demons manually until it will run. Right? Whether you need to shut down the machine, otherwise you need to stop the demon manually, then only it will stop. Otherwise, it will work 24/7. Demons, it will start along with the boot time. Until you shut down the machine, continuously it will run. That is called demon, right? So guys, see here, coming to RHEL 7.0 in 8.0 and 9.0 version also, having first process ID called system D, right? System demons. This is a first process ID. Coming to older versions like 6.0, 5.0, 4.0, 3.0, 2.0 versions having init D. Init D is a first process ID. Initialization demons and system demons. We'll discuss later, maybe Tuesday. The differences between system D and init we'll discuss on Tuesday. Not Tuesday means we'll have the Sunday session. We'll have the Monday session. Okay. Don't think we doesn't have the Monday. We are going to continue on Tuesday. Okay. This concept we are going to discuss on Tuesday. Monday we need to discuss some process related stuff only. Then other chapter, 12th chapter will have, right? At the time I will tell you what is the difference between system D and init D. So no need to bother now at present. Okay. Clear, guys? Got it? Right. So now how to identify the process status? See, guys, this is one process we are executing. See, ls-l is a command. ls-l command, it got executed by whom? Root user. The ls-l command, it got executed, we got output, the process, it got completed. Right? And we know only we are executing, we are getting output. Internally, what will happen? How we need to identify the status? Now we are going to discuss with the help of one diagram. Right? So don't get fear. Okay. The diagram, it will be looking like that only. But we doesn't have anything inside the diagram. Don't worry. After completing the explanation, easily you can able to understand. It's not a big deal. कहाँ पे है यार वो diagram? Where is? So let's see, guys, here. So let's see here. So this is a diagram, right? So this is process status diagram. Clear? This is process status diagram. Clear? Got it? Start कीजिए. Oppo, Vivo, OnePlus, iPhone, सब निकालिए, right? So finish? Finish, guys? Snaps. Okay. So let's see here. This is process status diagram, right? With the help of this diagram, we are going to identify the process status in our operating system, right? So let's see, guys, here. Who's going to generate the process? Parent process, right? Parent process, it is going to generate the new child process that is called fork. Already we discussed before, right? The fork is a new process. How many users we can able to create into our account, into our operating system? How many user accounts, how many user accounts we can able to create into our operating system? By default, 60,000. So can we say multiple users will have into our operating system? Very good, Anil. Okay. Can we say we'll have the multiple users into our operating system? Multiple users, they can able to execute the multiple process, right? Yes, no. So here, multiple users, for example, 4 to 5 users will have, guys. Those 4 to 5 users, they can able to execute the commands, right? Yes, no. So here the fork is a new child process, right? So multiple users, multiple new child process, it will be execute. So those people, they can able to execute. Simple, guys. We are trying to providing the input to the system, right? So like the same way, multiple users, multiple process, they can able to execute multiple new process. Those all the multiple process, it is scheduling into the ready status. Got it, guys? It is going to schedule into ready status. It's ready. It's not executed. It's ready to execute. Do you know computer blueprint, blue diagram? input unit. Did you remember that? Input unit, like output unit, arithmetical logical unit, control unit, and memory unit, like this will have. In the diagram, how you are going to provide the input to the system with the help of input unit. Input devices, for example, keyboard, mouse. So with the help of keyboards, mouse, we are going to provide the input to the system. This input, where it will store? Inside the RAM, right? Temporary memory. The input, it is not going to execute directly. The input, it is going to store into cache, right? RAM is a temporary memory. Inside the RAM, the data instruction it is going to store. From RAM, processor it will pick randomly. That is called random access memory, RAM. Processor also having one RAM. So if you observe, while you are trying to purchasing the laptop, while you are trying to purchasing the mobile, in processor specification, cache memory 3 MB like this will have. 3 MB, 4 MB like this will have. What is this cache memory? This is called static RAM. Our RAM is a dynamic RAM. Normal will have one chip, right? RAM chip. That is dynamic RAM. Inside the processor will have static RAM, right? This level 1, level 2 static RAMs will have, right, guys? So this processor, what it will do, it is going to get the data from RAM. Randomly, it is going to access, for example, 3 MB data. After completing the 3 MB data processing, again 3 MB. Then like this, it is going to access. So I hope you got it. Metadata story is different, man. Okay. So clear, guys. I hope you got it, right? So simple, try to understand. Random access memory, a RAM will have. So if you try to providing the instruction, those all the instruction, those all the input, it is going to store inside the RAM. From RAM processor, it will pick and it will perform. Finally, we are going to get the output through output devices. Like the same way here also. So multiple users, multiple process they can able to execute. Those all the multiple process, it will scheduling into the ready status. You can say this ready status is RAM. But we are discussing about Linux operating system, right? And here we should not say in our Linux operating system, Linux terminology is different. Because of that reason, we need to call here ready status or runnable. Clear, guys? For example, threads in program, right? Multi-threading you were saying, right? So that is in program. Okay. So general in our mission, I'm saying, you're saying threads first, the thread it is going to enter into the program. Then first it will check. Then another condition it will check. Then another condition. One more thread it is going to, that is called different story, right? So here simple logic, guys, we are providing input. The input it is going to store into the cache. From cache processor it will take, it will perform and gives the output. That's it. No need to think too much. Programs, Java, .NET and those all stuff. Simple logic. Providing input. So it will take, process, output. That's it. I said na, sugarcane mission. That's it. Simple. Right? So now here, this is ready status. In ready status, for example, 4 users will have 4 users, 4 different process they got executed. Thus all the 4 process, it is in ready status now. Right, guys? Now, kernel. Here in Linux operating system, kernel, it is going to perform the task. But in our general mission, processor, it is going to perform the task. That's it, na? Arithmetical, logical calculation, who is going to perform? Processor only. Processor is a brain of computer. You can say kernel Assume this, you can compare with processor kernel, because here we are discussing about Linux operating system details. So here the kernel, it is going to perform the process like processor, right guys? Kernel, it's not going to take the all the four process, guys. Kernel, it will take only one process from one user. Kernel, it's unable to perform the multiple users process at a time. Remember, I will prove, I will show you practically, don't worry. Clearly, what I'm trying to teaching theoretically here, everything will do practice. Everything I will show you practically, don't worry, okay? So now, multiple users, multiple process, they can able to execute. Those all the multiple process, it's scheduling into ready status. So for example, for processes, it is in ready status now. Now kernel, it is going to pick only one process. For example, one guy he executed ls-l. Another guy he executed maybe gedit. Another guy he opened vim editor. Another guy he opened some sleep command. 4 different process. First guy he executed ls-l, right? Kernel, it is going to pick the ls-l. Do you know first in first out? So exactly not. Try to understand. Exactly not. It's not like this. Who's executed first process? Only the kernel, it is going to pick the, as usually it is going to pick the first process only. But we can able to define. Maybe if he has some urgency, some different user he's trying to execute some different process, we can able to stop the current process. We can able to execute another process. It's possible. At present, assume this first in first out. So first user, he executed process, first user's process kernel, it will pick and then it will perform. Finally, it will gives the output to us. That is called exit zombie. Zombie means process completed. Zombie. Zombie ready. We'll have movie, right? Zombie means completed, dead, finished, wrapped. Okay. So multiple user, multiple process they can able to execute. Thus all the process it's scheduling into the ready status, right? So from ready status, kernel, it will pick only one process, then it will perform. Finally, it will give the output, output to us. That is called exit zombie. Right, guys? Then kernel, it will take another user's process now. Then it will perform. Again, we'll get the output. Then third user, fourth user, like this kernel one by one. It's not going to perform all the tasks at a time. The kernel, it is going to perform only one task at only one user process it can able to execute. Right. So many people, they have many doubts now. Then we are discussing about Linux is a multi-user multitasking concept. Then sir, he's saying like kernel, he's going to perform the only one task. So we have many confusions like this. You people, you're thinking, right? So now I'm going to give the clarity. Don't worry. While we are discussing about Unix and Linux, what I said, Unix and Linux both are multi-user, multi-tasking operating systems. But here it is like performing only one task, right? Let's see here. In one session, one task. We can able to open the multiple sessions, right? Assume this one terminal is a one session. It's a one parent process terminal. Inside the terminal, we are executing few commands. Those all child process. Got it. Let's see here. gedit file1. This is a command. So we are executing with the help of root user, right? So here we doesn't have the multiple user. This is a Linux class hello how are, sorry guys, are you? Right guys. This process it's running in foreground, right? Yes, no. This process it's running into the foreground. Go to terminal, then execute ls-l command. Can we able to execute? Now I hope you're clear. Kernel, it will perform the only one task at a time, right? Even if you're executing another task ls-l, it's not executing. Until you complete the current task, it is not going to execute the another task. That is what we discussed with the help of the diagram, right? Yes, no. So the current task, foreground task is gedit. We need to save and we need to quit properly, then automatically ls-l command, it will execute one by one. Clear guys? If the process, if it is running into the foreground, you are unable to execute the another process. We need to complete the current process, then only kernel, it will automatically execute the another process. Clear guys? I hope you got it right. Good. I hope you're clear about this part here to here. Output we got output. That means exit zombie. Now this process, it's not available into our operating system. It may be gedit, it may be ls-l. Those both the process are completed. Dead. Right? So मरा हुआ आज में फिर से जी सकता है. Like the same way. Dead process, you are unable to recover again, remember. Clear? The process, it got dead, completed zombie. Right? ls-l and then gedit. Gedit process also completed. We doesn't have. If you need to call again, you need to execute new process. ls-l also completed. We doesn't have. So it got executed. We doesn't have the ls-l process also. Clear guys? That is called zombie. So जो completed हो गया, वो process को हम लोग फिर से recall नहीं कर सकते. जो process रहता अपने operating system पे, the process it's available into your operating system, then you can able to recall. I'll tell you, that is also how we need to keep into the background everything. So I hope you got it guys. So here, from here to here, see what I am trying to giving the information in the sense, gedit, it's a current running process. We are working with one editor. It's running in foreground. You are unable to execute the another process. That is what I'm trying to say. Whatever, if you want, you can write the data. We did save and we closed. That means we'll have the file one into our operating system. File one is a property that is called resource. It's not a process. Gedit file one is a process. File one is a file, right? File means it's a data, right? We have the difference between data and process, right? Yes, no. So next part, so we'll say this. And you people, you are thinking we'll have the file one into our operating system. That means we'll have the process into our operating system. Gedit is a process. Gedit process completed. File one is a resource. Got it? So let's see guys here. Now we'll see this part. What I need to give the answer, man? Huh? Who's that guy? Praveen. Huh? Praveen, in which language you are comfortable? Huh? What I said, if one process, if it is running into the foreground, you are unable to execute the another process. Even if you try to executing the another process forcefully, it won't accept kernel until you complete the current process. Right, guys? Now we'll see this part. So now few process, it's ready status now. Already it's running. Instead of close the process, we need to stop the process. For example, you're listening music, maybe with the help of few apps, music apps, right? Spotify, something will have few apps, right? Wings, music, Savan, like this. So you're using headphones, you are try to like listening the music, you are enjoying the music with loud sound. Okay. Then one guy he came to you and then he's asking some instruction how he need to travel. For example, he's tried to speaking with you. Can you able to hear him? No, right? What we need to do? We need to stop the music, right? Are are you going to stop the music, or otherwise you are going to close the entire app? Just you are going to stop the music for few minutes, few seconds, because as a human we are unable to listen multiple instructions at a time. Whether you need to listen the music, whether you need to discuss with him what he's trying to asking to you, you need to understand, right? Only one task. So then what we need to do? The current task temporary we need to stop. We are not going to close the entire app. I hope you're clear, right? The current process we need to stop. Then we need to execute the another process. After completing the another process, again you can resume the previous process. Stop process. वो बंदा चले गया. So you're given the instruction to him. Then he went outside. Then you are going to start again. That's it, no? You're going to start the music again. You're going to play the music again. Like the same way here also. Okay. Now we are executing one task. The task, if it is running into the foreground, always we are unable to execute the another task. Right? Then what we need to do? We need to close the current task, or otherwise we need to stop the current task. Right? Already we know how we need to close the foreground task before. So we save the document and then we close the gedit. Now here, I'm not, if you close the gedit, again you are unable to get the gedit, guys. You need to execute new task. But here, instead of executing the new task, what we are doing in a sense, we are going to stop the current task. We are not going to close the gedit permanently from our operating system. We are going to stop temporary. Then after completing the current task, we are going to call again. We are going to resume again into the foreground. That is what we are doing. Suspend and resume. So how to suspend and resume, we'll see. So let's see, guys, if you want, you can use gedit or otherwise any command, but the command it should running into the foreground. Like this command you should use. Sleep command. Sleep command will have sleep 10,000. Okay. Sleep is a command. It will provide you sleep timing. After 10,000 seconds, we'll get the prompt again until you won't get. You are going to use the sleep command into the scripts. So now we are going to terminate. Okay. Okay. So again, I'm using same, guys, gedit, then file one. Gedit file one. The process it's running into the foreground. You are unable to execute the another process into the session. Right? So here it's running. you can able to type anything. Got it, guys? You can modify, you can type, you can whatever if you want, you can do. So if you close the current process, then only we can able to execute the another process. Instead of closing the current process, we are going to stop. How to stop? See, guys, go to terminal, Control Z, Control Z, Control Z, whatever if you want, you can say. Control C, not G, Control Z, 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 zebra. Okay. So now, can we able to execute another process? Yes. Jobs is a command. We can able to find out the background jobs. Gedit process, it's stop. Got it, guys? Now you can type anything. You are unable to type now because gedit process, it got stopped, but it's available into our operating system. We can able to resume. Right, guys? You can execute any command. We can able to execute now. Okay. While we are trying to editing the file, at the time suddenly we got a one work. Then instead of closing this file, what we did, we stopped the file. We stopped the current process. Then we executed few commands. Then again, we need to work with that particular file. We need to call that file again into the foreground. The process, it is stopped now. You are unable to work with that particular file one with the help of gedit. Again, you need to resume. You need to call this process into foreground. How to call? Simple command fg percentile job id. Jobs is a command. You're going to get the job id, status, and process name. Plus means present, minus means previous. If you're executing multiple process, current process, present process having plus, previous process having minus. I hope you got it, guys, right? Present process having plus, previous process having minus. Got it? Clear? Good. FG percentile job ID. What is the job ID for gedit? One, right? One is a job ID. FG means foreground. Percentile, one job ID. Then hit enter. Now it will work. You can type whatever if you want. Got it, guys? Clear? How to stop the process? How to stop the current process? Control Z. Control Z is a option shortcut we need to use to stop. Okay. Again, resume. With the help of FG command, we can able to resume the stop process into foreground. I need to terminate the process permanently. I doesn't need this gedit process into my operating system. Control C to terminate. Control Z to stop. Control C to terminate. Got it? So I hope you're clear, guys. If you use Control C, you are unable to recover, you are unable to recall the process again. If you're using Control Z, it is going to available into the background in stop status. We can able to resume the process again into the foreground, right? If you use Control C, that's it, finish, terminated. We doesn't have the process into our operating system. Clear? I hope you got it, guys. This part from here to here. This line also, I hope you clear. This line also, I hope you clear, right? By seeing this diagram, maybe like we'll have something like this we are going to fill. After completing the session, definitely it's very easy to understand. It's not a big deal, right? And next, this part. Huh? Okay. Running user. बताऊंगा, ये complete होने दो पहला, right? So I am coming one by one, right? Percentile is option, guys. Percentile job ID you need to provide. That is option. So that is a syntax. Percentile means what I need to say. Percentile means percentile only. Okay, comma means comma only. Okay, right? So let's see, guys, here. Sleep. Now this part we are going to discuss. Sleep. We are going to make the process into the sleeping status. Right? Coming to sleep, we have three types of sleeps. Until, so we need to complete this diagram, guys. Until the completed diagram, I'm not going to leave you. So hardly 15 minutes, 10 minutes it will take, that's it. Okay, right. So coming to sleep, three types of sleeps will have. S, D, K. S means process interruptible. Guys, I'm trying to teaching to you people very slowly today because this is a very, very important concept. Right? So S means process interruptible. S means process interruptible. Right, guys? S process interruptible. D process uninterruptible. K process killable. Killable. S process interruptible. D process uninterruptible. K process killable. Right, guys? S, if we having S, from where we need to get those, all the S, D, K, everything I'll show you, don't worry. If we having S, process interruptible. Right, guys? If we having K, process uninterruptible. Sorry, K, killable. D, uninterruptible. S, process interruptible. D, process uninterruptible. K, process killable. In sleep status will have. Okay. In sleep status will have process interruptible, uninterruptible, and killable process. Clear? Good. Next, let's see here how we need to make the process into sleeping status. Sleeping means we are going to make the process into the background. The process, it should run into the background. I hope you got it, guys. Stop means it will stop. We are unable to utilize. Now we are trying to making this process into the background, but the process, it should into the running status. That is called sleep. I hope you got it, right? That is called sleep status, right? So clear. Let's see here. Go to here and same gedit I'm using. File 1, open. This process, it is running into the background, right? This foreground, right? Then how to stop this process? How to stop the process, guys? Control Z, Control Z to stop the process. Jobs is a command. Gedit file 1 process, it got stopped, but it's available into our operating system. Now we need to keep this process into the running status, that is called sleeping. Background running means sleeping. Coming to sleeping, three types of sleeps will have. S, process interruptible. D, process uninterruptible. K, process killable. Right? Now let's see, guys, here how we need to make the process running status into the background. So we are not going to keep the process again into the foreground. If you keep this gedit process into the foreground, you are unable to execute the another command. We need to work with gedit as well as we need to work with terminal. multiple process we need to run at a time. PG is a command percentile job ID. FG to call the process to resume the process in foreground. BG to make the process to run the process into the background. Simple commands, guys. FG, BG. FG means foreground, BG means background. Okay. So jobs is a command. See, guys, here running. So gedit file one. I hope you got it, guys. Clear? Right. So it's running into the background. Then you can execute any command in terminal, as well as if you want, you can execute something like this. Both it's working now, right? Then you need to terminate this process again. Then how? We need to keep the process into the foreground. How to keep the process into the foreground? FG percentile job ID 1. Then gedit it is in foreground. Control C to kill. Terminate. I hope you got it. This part also. Clear? Here to here, I hope you're clear. Here to here, I hope you're clear. And this is also, I hope you're clear, right? This part also, you're clear. Now what is this? Right? Syscall. Already we discussed while we are discussing about man command. System call. Kernel. For example, I am a kernel. I am kernel, right? For example, one user, he came to me. One guy, he came to me, and then he's asking one doubt. In between, one more guy, he came to me, he's asking some different doubt. Can I able to give the answer for both the people at a time? It's possible. If we have same doubt, then we can write. Usually, kernel like the same way. What I need to give the answer to another guy? So I need to give the preference for first guy, and I need to inform to the second guy, go and set. I will call you after some time after completing this current session. So like the same way here also, multiple user, multiple process they can able to execute, right? For example, one process, if it is running, one user, he executed another process forcefully. Then kernel, what it will do in the sense, automatically the process, it is going to return to the user. And after completing the current process, automatically it is going to call the process from user. That is called system call. I hope you're clear about this diagram now. Remember those letters R, T, Z, S, D, K, X. I will tell you day after tomorrow. We doesn't have much time to discuss those old stuff, right? I will teach you day after tomorrow. Tomorrow, no session, no class, online. Guys, don't log in tomorrow. Okay, Nagireti. Right. Right, guys. So if you having any doubts, any questions, please. You are ready to go, huh? We didn't complete the session, man, till huh? Everything is pack up. సర్దేశారు బుక్కులు టప టప మూసేశారు, బ్యాగులో పెట్టేశారు, జిప్పులు వేసేశారు బ్యాగులకి. రైట్, యూ వెల్కమ్ పవన్. So if you having any doubts, any questions, please, guys. Guys, tomorrow no class. 4 to 5:30 only. Remaining classes is available. Morning 6 available, 9 available, and then 11 to 1:30 also is there. You need to attend. You need to attend means only AWS peoples. Okay. Okay, guys. See you. See you day after tomorrow, Monday. Okay. Bye. Take care. Happy weekend.